In this unit, we're going to cover the linear light of the LED linear lighting system. This is the cornerstone of every LED linear lighting system because it's the area where quality, design, everything is so important. Having a good quality linear light is going to give you a long-term installation. So I'm going to review the components so you understand them. And then in the other units, I'm going to talk about what makes them good quality. We have an LED flexi strip. Everybody's pretty familiar with these lights. These strips are made up with small LED diodes. 1, 2, 3. You can see those yellow buttons there. In between those diodes, you have resistors. Now I'm just going to go through the layers that people are accustomed to. So we have the resistors and the LEDs all mounted onto a circuit board called a PCB, or some people call it FCB, flexible circuit board, because it can bend. And on that circuit board, we have a white protective layer. You can see a small scratch I made on it to show you it's just a protective area for the circuitry. Underneath that, we have a 100% copper layer. Then we have an insulation layer. Some people don't even put an insulation layer. They just go straight to the 3M. But you have an installation layer. Then you may have another extra copper layer for extra heat sinking. I'm just going to turn it around behind so you could see. So that's the insulation area that I just pulled off. And this is the last area of copper to protect the LED. Now I don't have a device thin enough to strip it, but if I stripped it again, you would have seen the printed circuit board on the other side. How do LED strip lights work? It's the same way, passing a voltage across the semiconductor, but it's just on a printed circuit board this time. In most cases with the LED strips, you have variable resistors like this. You have various chip types, and these chip types and resistors dictate the brightness of the LED. LED strip lights tend to be constant voltage. So it could either be 5 volts, 12 volts, 24 volts, 48 volts. Rigid LED strip lights tend to be constant current, and you see them in integrated fixtures. So there's a voltage range, but it's constant current. So they drive the LED at certain amperage. In this course, we're going to be focusing on constant voltage LED systems, just to iterate. I thought I should let you know that constant current could also drive LED linear lights. The lumens in LEDs is a measurement of the light emitted from the diodes. They usually say lumens per meter or lumens per foot. So what they do is they measure whether it's a foot or a meter, and they get the individual light output out of each diode to give you the total light output. There's also efficacy, which is lumens per watt, just as we discussed previously. The different correlated color temperatures happen at this level depending on the phosphor mix that they use to get the white light. Color rendering is also produced at this level. Ingress protection, these could get an IP rating through having silicone on top of it, silicone all around it, or having silicone extruded with it. Now, it's important to bear in mind that every time you put silicone around, you also compromise thermal management. You could note that this is the only heatsink LED has. It has this copper layer. If there's a need to have more heatsink, you need to add more copper. But imagine this light being trapped within one of these silicone casing and expecting these two to last the same time. They don't. What often happens is that you start to get bad segments, or the heat traps and destroys a resistor, and you get patches. I'm sure you've seen that already. This is what I thought was an IP65 back in the day, because companies said this was IP65. This is actually now rated at IP5 and then 2 on the water level. So strong jets for a period of time could cause this to crack. If you get a crack or a fracture here, see how easily my hand fractured it? That water is going to get inside of this. Right now, I have this rated at IP65, which is a case around the whole LED. It's not filled with anything, but it's wrapped around the whole LED casing. What would make this IP67 is if we took silicone, filled the LED with the silicone, and then wrapped it around in this case. So you would have an inner layer and an outer layer. Finally, what you would consider an IP68 LED, you could see it's factory sealed, and this whole LED light is extruded into one cohesive unit, or one solid unit. This will be considered an IP67E extruded or an IP68 LED. And this could be submerged under 2 meters of water, and that whole thing is extruded as one unit. The common electrical values we look at LEDs is the wattage or the power. We look at the amperage, and we look at the voltage input. I will talk about those further in the other unit. That brings us to the end of our LED linear lighting overview. Now I'm going to dig in quickly to the chips so you understand the technologies that integrate onto the flexible circuit board.